Okay, so this one is how do the speeds at 3 different times compare with each other. So I'm just going to sketch out the plot that you can't really see very well. So we've got X, and we've got Y, and the plot has a parabolic motion like that. And we have tangential velocities here, here, and here. This tangential velocity is not very tangential for me, so I'm just going to make it a little bit more tangential. There we go. So V0, V1, and V2, T2, T1, and T0. This one should be slightly more flat than it is, but we can just pretend. Okay, so it's asking how do the speeds at 0, 1, and 2 compare with each other. Remember that a velocity, say V0, is going to be some x component plus some y component, while our speed is going to be the magnitude of this, which is the square root of Vx squared plus Vy squared. Now this problem doesn't ask us to do any actual math, but I'm just pointing that out for now. So then at T1, which is the peak of our orbit, Vy has gone completely to 0, but gravity only acts in the y direction, so that means that V1, our velocity, is still going to be Vx x hat. So it'll be an identical x velocity, assuming no wind resistance, of course. So our speed is then just Vx. So it's completely just the x part, and obviously as this is x plus y and this is just x, this is going to be less than our speed at 0. So at 1, the speed is less than our speed at 0 and is, without wind resistance, exactly equal to the x component velocity that we started with. And then at 2, at T2, acceleration has now brought our Vy all the way to minus Vy. So we've gone from 0 at the apex to minus Vy at the landing point. Okay, so it's all perfectly symmetric. So then at T2, Vy goes to minus Vy. So our V2, our velocity, is just Vx x hat minus Vy y hat. But then if we look at our speed, it's just the square root of Vx squared plus Vy squared, because a minus sign when squared becomes positive. So then that exactly equals our 0 speed. And so if to wrap it back through, right? If we have some speed at T0, then at T1 the speed is going to be less and exactly equal to the x component. And then at T2 it's going to be exactly equal but acting in a negative y direction. But x is maintained throughout the whole motion. So if we look through the solution here, that basically talks through everything and says the velocities v0 and v2 will be equal in magnitude and will be greater than the v1, which is what we said. So that looks good.